or this is our crowd?
I
We
think
can
we'll
maybe
have a
wait till like
YouTube.
6:10, I guess. We can
Yes.
just wait till like
That's okay.
6:10.
That's okay. Yeah, YouTube now is fine. Okay. So what I'll do is I'll give you a quick introduction to what system design is. But before that, let's do a quick show of hands. How many final years or people going to final year? Basically, who all are in Arnav's batch? Okay, I see 1, 2, 3, 4, 5. That is it, I believe.
There are
Okay.
more people who haven't raised hands. But yeah.
Okay. That's okay. How many people in third year? Just okay. About I think two, about 4, 5, another. And anyone in second year? And now you can put down your hands. Any second years?
Second years are not here. I think we have not done the recruitment for them, and it's just
Okay,
yeah,
got it. So just
just
final years
making it.
and third years, great. Any
Yes.
alumni, like people in the batch after Anumeya's batch? I don't remember the name. I don't remember Arpita's batch, basically. Okay, no, great. All right, so just final years and third years, that should be great. And whoever's probably watching on YouTube, if there's someone watching on YouTube, that should be great as well. But the reason why I wanted to ask was just to sort of ascertain the kind of familiarity we've had. So third year's quick question for
This
you. Have you
sorry, just before we
attended?
get started, your camera isn't visible on the YouTube stream. Not sure if that's an issue.
You might have to make me
That's
presenter or something. One second.
okay.
Uh, one sec. Why am I only
Present.
meeting organizer? Yeah, you might have to make me presenter. I think
Yeah,
I am a
like
guest
we can
at
see
the
your
moment.
screen. Like we can see you on our screens. I don't know why it's not like showing on YouTube.
So what you'll okay, yeah, someone made me a presenter. Now I think, oh, I think you made the just change it to the other account. So I joined via my phone and my laptop. Just change the one with the screen as the presenter. You should see to Salman Shah guest. Oh, maybe let me put a chat. Okay, I can't put chat. Or 1 second. Yep, I think. Is it visible on YouTube now? Hello.
No, I don't think so. You're spotlighted. I mean, it shows on my screen like whoever's presenting, I think others are presenting, no? Like, is it visible on your screen? Salman's video.
Okay, 1 second.
Right, there you go. There you go. Yeah.
Window.
I think he was just on.
Give me a sec. Can you see stuff now?
Yeah. I think it's fine now.
Cool. I believe you'll see an empty Firefox window. Let me just open docs.new. Okay. Let's start, shall we? Arey yaar.
Salman, can I just introduce our audience once? I mean,
Sure, please.
yeah, okay. Okay. Hi everyone. Welcome to this system design session. Our speaker for the evening is Salman Shah, who is currently a software development engineer at Microsoft, and an ex-SDE at Myntra. This open discussion will help you gain a perspective on how systems are designed and built in tech industry. I request everyone in this meeting and our YouTube audience to be as interactive as possible and feel free to ask any questions they have. Over to you, Salman.
Okay. So let's go with this. So, ideally, we basically going to talk about system design, and it's been a slight while since I've done a bit of system design. But to just put into perspective, system design is usually not asked at the fresher level. You would typically expect people with some sort of years of experience to deal with system design during interviews. As part of teams, depending on where you will sort of work at, you might get some certain experience working with system design. And out of all the places that I've interviewed, I think apart from probably Kochek and Razorpay, I don't think anyone else asked for system design. It usually starts at an SD2 level. If you're interviewing for SD2 at most firms except Walmart, you typically might be asked. It depends again, company to company. There's no set rule as to where system design will be asked for you. But typically, 3 to 5 years of experience. Some companies ask more than 5 years of experience. Everyone asks. Okay, that's a quick insight into system design. Now, coming to what exactly is system design, what are some concepts that we would like to sort of understand, and what are things that we can do to sort of build our so let me just sort of type it out for us. So the objective of this particular session is understand system design, build on system design concepts. We'll primarily talk about HLD. Sorry, we'll talk a bit about HLD. We'll talk about something called as LLD, and majorly apart from this, let's see, so maybe a bit about reading about system design. Okay. As far as understanding system design is concerned, we'll talk about the what, the why, the how. Okay. So yeah, I think that's to sort of start off, and we'll probably take an example at the end, which is sort of more of a technical discussion. Although I'll sort of try to involve at least the people on this call. I would expect you to keep answering. Feel free to ask questions. No question is dumb. And just in case there's something that's not very clear to you, or stuff that you would feel that you'd sort of better understand if I repeat it, feel free to sort of stop me and we can talk about it as well. All right. So that's I think what I had to say in the beginning, and let's probably start.
Salman,
Yeah.
you're not sharing your screen.
Oh, sorry. Thanks for pointing that out. Can we see my screen now? Google Chrome
Yeah, it's
window.
visible now.
Awesome. Okay. So, can you see one screen? Can you see two screens? What is it?
It's one.
All right. Awesome.
Yeah.
Okay. So, so sort of talking about system design, right? Uh, for when we sort of start off with the definition, right? So, let's just take one person on the call. Let's start with Arnav. All right, Arnav, what do you think system design, given the name, would be? And yeah, let's sort of start off with that.
Sorry, could you just repeat that? I missed you a bit.
Just what is system design? That's the question.
Okay, so yeah, basically it just means that if you're trying to build an application for a certain use case, you want to be
Okay.
able to position the various components of that in a way that maximizes certain metrics like latency, throughput, stuff like that. Basically, your
Okay.
high-level design of the various components involved, how would they be
Okay.
placed, how would they interact with each other, what do each of them achieve, so on and so forth. So that's the basic
Okay.
idea of system
So I
design.
think again, that's sort of a good definition. Let's try to sort of uh, let's sort of uh, let's try to make it more simpler, more layman. So based on what Arnav said, essentially we are trying to place components in a system and design several aspects of it. So system design is just not limited to just sort of the architecture. It also includes the different components that would be there, the different interfaces that the system itself would have. So one of the more popular architectures or technical architectures in recent times has been something called as microservices. So let me probably just keep noting down words as we talk about them so that we're able to follow. So understand. Yeah. So one of the bigger things in our times has been something called as microservices. So now when we talk about microservices, we are essentially looking at let's try to look at the motivation behind microservices, and then microservice is not something that's directly related to system design. Just sort of you can again build systems without system design, but the idea that I'm trying to propagate over here, and we'll sort of understand why I sort of want to explain microservices, is all right. Let's probably take someone in the call who has an idea about microservices. Anyone? Just sort of speak up. It's okay. Yeah, I don't want to point people. Okay. Kritik, when you go.
Um, yeah, can you hear me?
Yep, we can.
Yeah, so basically, we have like two types of architectures mainly. One is microservices, like you mentioned, one is monolithic. So
Mhm.
microservices basically breaking down the system into multiple components basically, and like uh, the system is created by like interactions between those components. And like in a
Okay.
monolithic system, it's basically one large component which is
Mhm.
doing all the heavy lifting. Yeah.
Mhm. Yep.
Yeah.
So absolutely what Kritik said. Here's how to sort of look about it, right? Let's take a very familiar example that we have. At college, we have a system called Iris. Iris in itself is a monolithic system, at least at the time when I was working with it. And the primary idea, or rather, there is one particular service which sort of does everything. Okay. If I were to break Iris from a monolithic to a microservices architecture, I would probably start with isolating the login or the entire authentication system separately, the entire student management separately, the probably or each of the modules that are there. The placement system would be a different application in itself, and you have all these small applications which sort of interact with each other. Okay. So and the reason why I want to sort of talk about these two is, can anyone sort of tell me what are the trade-offs when you move from, let's say, a monolithic system to a microservice system, right? So one important concept that you sort of need to understand in system design, whenever you approach any system design problem, is this is not like your DSA problems, right? So you can never have one correct solution. Your solutions are always subjective to the requirements that you have. Okay. So there are cases where you might as well have monolithic systems which perform much better than microservices. Again, that depends on the requirements that you have. So yeah, when we talk about trade-offs, what do we think are potential trade-offs of microservices? Anyone? Sriram?
Yeah. So can you hear me?
Yep.
Yeah. So like one way we can think of it is like let's go with advantages maybe of like microservices over like monoliths. So each of the different systems are like very independent. So it becomes easier to manage them, like say test them, or like you say if one system has like higher demand, then we can scale that independently. That's one way of thinking about it. But on the flip side, I can also think of it like there is a lot of like uh, things that need to be discussed between the like different modules. So there might be some networking that might take some time extra, so that might slow down the things a little bit, but like that depends on how.
Latency.
Yeah, the latency might be like a valid factor also for us. So these are
Okay.
some things I think we would have to think about
Absolutely.
mainly.
Absolutely. So yeah, you basically make a trade-off between availability and latency. Uh, in a single system, you or rather you basically create a single dependency versus, let's say, a dependency on you sort of have multiple independent services. Then so let's say, for example, let's take a very simple use case. Let's say we have a login use case, right? Where let's say for some reason, or rather than login, let's take a more advanced example of how you have course registration, for example, right? No, actually, that wouldn't really work. So the basic idea is that, and let me probably think of a much better example, which is not something that I can think at the moment. But the basic idea is that if one service goes down, your system can still hold, which might not be the case in your monolithic system. A very simple case example being, let's say you have this particular use case where you are supposed to make a call from one service to another. So typically what happens in microservices is, so there are multiple microservice architectures as well. That's something that's probably a much longer session and a much different session, which we can cover someday. But one of the architectures in the microservices world is using something called as a gateway layer, and this is something which I sort of worked at when I was at Mintra, where what you do is you have the basic idea is you have, let's say, a client system, and this basically, let's say you have a gateway service, and you would then call a certain microservice post this. Okay. So what typically happens is you have a middle layer service which is basically called, and then there are, this could be, let's say, a course registration service, or another example is, let's say, if you have a different API path, you could do the same thing with, sorry, yeah. So you could, let's say you have an authentication service. So what you would typically do is, the user flow would be, once you sort of, you get a username password, you sort of log in, and once your credentials are returned, you sort of go to the course registration page and make whatever calls that you require. And this is one way of designing microservices. Now, what happens is, one of the things that you can sort of do is, let's say if your authentication service for some reason goes down, you can, and this is what happens in system design as well, based on your requirements. Let's say you store. There are examples of. There's a concept of something called as cache. Are all of us aware of caches? Okay, as a very basic understanding of caches. Caches are basically memory which is stored. There are different types of memory, and uh, without going into the detail of that, basically memory can be accessed. So as of today, there are as you have. So if you guys do remember some concepts related to primary memory, secondary memory, RAM, and disk storage. So there are certain ways in which you can cache certain data, and one of this could be, let's say, login data. And what you do is, at your gateway layer, you essentially cache certain information, which allows you to sort of mitigate the instance where, let's say, if for some time your microservice has gone down, you are able to log into, you are able to still fetch some of the data via your cache. And this is a very random example. Don't really have a so one of the use cases which at least I do remember is fetching. One of things that you sort of do is, uh, are you guys aware of SEO? Uh, Anyone? Search engine optimization. So just to sort of give a small example on SEO, uh, basically what happens is, let's sort of chuck that. I think that'll just go way off topic. So the point I'm trying to make over here is microservices. Coming back to system design, there you essentially are designing multiple systems, as Arnav pointed out. And let's sort of try to take an example uh, and sort of understand what we mean by this. So uh, hmm. So, all right. Do we have Nishant?
Yeah,
Hey,
yeah,
Nishant.
yeah.
Hi. All right. So what we're going to sort of do right now is we're going to sort of take a simple example, and as we go along with the example, I'm going to explain certain concepts. And so, are you aware of? I think we're all aware of one particular service that we use today, which is a URL shortener, right?
Yeah.
Uh, okay. So, Nishant, what I would like you to do is define the requirements for a URL shortener that you require. Let's say for a college purpose, right? So, for example, web club, for every session, let's say they need some sort of a URL shortener, right?
Yeah.
Uh, uh, yeah, we will sort of start off with the requirement for web club, and then we'll probably go into a big. We'll sort of try to scale that and make it as a bigger requirement. Instead of web club, let's say sort of take it that every club in the college needs uh, a URL shortener service, and we're designing this common URL shortener service. Okay, so the first step in system design is defining the requirement. This is the most important step because if you change one requirement, your entire system design can completely change. Does that make sense?
Yeah, that is correct. Yeah.
Okay. So steps in URL shortener, and this can be sort of any example. Also, the process that I at least follow is not something that is in paper. It's something that I follow to sort of solve a system design question. But this is not the only way to do it, and this is definitely probably not the best way to do it as well. There could be better ways. Again, system design being very subjective depends on a lot of stuff. All right. So yeah, let's start with the first thing, which is requirement. Right. Yeah, Nishant, go ahead.
Um, so yeah, like generally, like I'm guessing for clubs, like if they have to send out links, it's usually for events. Events don't
Okay.
occur that often, and so your links that you shorten, you can keep it to like so usually like how link shorteners, or as far as I've seen link shorteners work, they have like um
Mhm.
well the let's say bitly, they have bit.ly / a certain number of characters,
That's
right? And
okay. You
that
can not worry about the domain. Let's just worry about
okay.
whatever comes afterwards, the
After that, yeah, yeah.
bit.ly.
So yeah, so that the length of that string is basically it sort of helps you define how many links you can shorten, right? Because
Okay.
you're gonna uniquely map this string of characters to a URL, because
Okay.
that's how you're going to map it back to the shortened URL, map it back to the original URL. So since we don't have too many links coming out from each club, considering there's going to be
Okay.
one or two events each month, that the length of that string doesn't need to be too long, and so like that's one thing.
So do you
that
want
I
to
guess
put
you
a
can
limitation on the length of the string?
Like I don't know. It's not really necessary, but that's something we can optimize if needed, right? Because
Okay. So
we have a
since
general idea of an upper bound of how many events are there. So
okay, so let's say every club conducts 10 events. There are 20 clubs. There are probably 30 clubs, let's say, or let's even take 40 as a higher bound. So 10 events per club, about 400 events per year. Let's make it 500. So we have about 500 events per year.
yeah.
Okay. So you still have not given me any requirement, right? Do you think you have a requirement?
Okay.
All right.
My bad. So yeah, I would need well, essentially what I would need from this URL shortener is all these 500 events should uniquely map to like different URLs that I can always access. So whenever, like even in the future, like whenever I want to access these URLs, I should be able to access them from these shortened URLs.
Okay. Let's go one step basic. So let me probably start, and why don't you ask me questions? Okay. So one of the fundamental requirements that we have over here is we will be given a long URL. Okay. So as an input, you are given, let's say, long URL, and you have to return. So this sort of happens sometimes with services, sometimes you don't. Okay. You basically return a shortened URL. This is any URL shortener service will allow you to do this. The second requirement is define custom URLs. Correct. So like in today, for example, for today's meeting, we had a custom URL which was defined. Google Meet typically gives you any random URL, not any random URL. They have a certain pattern for it, but they will return a certain URL back to us, right? So these are our basic uh, requirements. Do we have any questions on this?
Yeah. So how many long URLs can I like map to shortened URLs? And basically, what is
Good
the
question.
sort of limitation on custom URLs as well? Like, what can I not enter in custom URLs?
Good question. So I think for the first question, right? How many long URLs? That typically depends on the length. If we are defining a length to the shortened URL, right? Because at the end of the day, the shortened URL is also a column in some database row, and that needs to be defined, right? You can't basically have an infinite string limit, right? Uh, Now there are two parts over here when you define a constraint. One, you sort of look to satisfy an existing condition. Okay, so in our case, we said we have like 500 events, and let's say we want to sort of run the service for 20 to 30 years, or something, or let's just say 5 to 10 years, right? So we really have about 5,000 URLs. But let's say tomorrow I want to sort of deploy the services for this service for all colleges in India. Okay, and there are about, let's say, 1 lakh colleges, right? And each of them, let's say, have 500 events. So suddenly I'm looking at 5 crore URLs. So uh, when I design a service, I need to understand what is my existing requirement and what is the potential future requirement of the service, right? For example, in my case, I'm looking to sort of establish this service across all engineering colleges in India, let's say, for example. Okay, so understanding that and building on that constraint is very important. Let's say in my case, what I do is uh, I sort of define, what you can have, let's say, a maximum of 10, for example, right? So 26 power 10 would, so each place can have like 26 characters, and 26 power 10 is probably a very huge number, which I don't know the value of. But let's just sort of look at it. Uh,
Yeah. So that's another thing. Are we limited to only the lowercase alphabets, or is there more that we can use?
10 power 14. Uh, that that in itself, that is a very good question. Are we limited to lowercase? Do we make a differentiation between lowercase, uppercase? And it can sort of go either way. Let's say for the cases of my service, the URL is case insensitive. Okay, so I just want to sort of stick to 26. I only want to allow alphabets. I don't want to allow any sort of special characters and all that stuff in my URL. Yep, and I am not really allowing numbers at the moment. Okay. So this is the first part. Okay. So it all depends on since I'm the one defining the requirement, and I'm the one adding constraints. That's how my service will also be constrained. Because right now I'm saying even my custom URL will have like 10 characters. So I can't have very verbose, I can't have verbose URLs. And as part of my requirement, I am fine with it, right? So to any system design that you do, there are always two parts of the problem. One is the product side of problem where you'll sort of have a product manager or someone from marketing or whatever come to you and say, you know what, I want my customer to do this. And one will be the technical side where you'll sort of uh, you'll be constrained with technical requirements, right? In our case, whatever we've done till now is basically handle product requirements. Technical requirements would be, let's say, if I make this 10 characters into 20 characters, for example, okay, I am almost doubling the amount of space required in my database, right? So 10 characters into whatever KB that would be per column, I automatically increase and double that to 20. Now, once I make that database storage into 20, even though disk space is cheap, I still have to pay. So instead of once when I finally, let's say, hit a one, and when you sort of design at scale, instead of having 1 TB, I'd probably have 2 TB. Now I have to pay for 2 TB of data. Again, this is at a very large scale. So then, am I constrained with paying for 2 TB of data, or I'm okay with paying for 2 TB of data because the trade-off is that I'll probably have more customers. So these are all the questions that you sort of ask as you sort of build on your system. Again, we're doing a very simplified version of this, and there's a reason why freshers aren't really asked questions like this. But I hope you guys are getting some sort of an idea as to so system design is a lot more about asking questions, and I sort of wanted to display that, but I think yeah, we sort of have a good job. All right, next question. Do we have any other questions, sir? So we've defined yeah, I think you had two questions. The first one was with respect to what will be the number of URLs that we can sort of save, and I think I gave an answer to that. What is the next question?
Sort of, yeah, like how do we define our custom URLs? Can we have like dashes and like, yeah, and again, you're saying 10 characters, and you're not allowing for special characters. So how do we make sure that like there are no clashes with custom URLs? That's another thing that we have
So
to.
that is a fundamental requirement as it is, right?
Yeah. Well, when we're using randomizing, okay, sorry, go on.
Yeah, so that is a fundamental requirement of your entire service, right? Where you need to ensure that, at least at this point, okay, you need to ensure that you are outputting unique URLs, unique shortened URLs for your service, correct? So your URLs can go both ways, right? You can either start from, I mean, you obviously need to store both, you need some way to sort of uh, move from a shortened URL to a long URL or a long URL to short URL on your service. And your requirement is that either of the two should always be unique. For example, for one short URL, you can't have two long URLs, and for one long URL, you can't. For one long URL, you could probably have two short URLs. Again, depend on our requirement and the kind of system that we develop, right? So yeah, So how will we place constraints on this? We'll probably talk about that during the design system when we do the actual design system. But are we clear that even if we input a custom URL, we need to ensure that it gives out. We basically have a unique custom URL. Does that make sense?
Yeah. So the how part will come later, I'm guessing. Like how we
The how
ensure
part
that.
is not your requirement, right? Your requirement is what.
Yeah.
So you
Correct.
basically ask what. Correct.
Okay. Yeah.
Okay. Anything else? So okay.
I
Do we want some sort of a timestamp on our service? Let's move on to someone else. Let's give someone else a chance. Bhaskar, how are you? I don't know if you're
Hey,
hi,
hey,
hi Bhaskar. All right. So what do you think? We've given some uh, URLs. We've given some requirements. What do you think should be our next? Do you think we should add more requirements, or is this okay?
uh, for now it seems okay. I think one more thing would be how
Mhm.
long you're like how much long URLs are we trying to shorten?
That
Like
so that
would
is
that
that is not something that we're looking to constrain. To be honest, uh, the length of the URL. So there is a certain limit for URLs as well. I think so. URL length limit. So whatever that limit is, so it's 2083 characters from what I understand.
okay?
Internet Explorer. Let's assume it's 2083 characters, right? So that is going to be our limit, whatever the internet allows, right? Because we are
Yeah,
okay with allowing any kind of URL length. So that's basically our limit, 2083 characters. Does that make sense?
yeah, okay. So
Okay. Uh-huh.
will be mapping each URL with this basically 2083 byte space, basically 2083 like the max length.
Yes. Yes. 2083 2083 characters would be the maximum length of the
So
URL.
one
I
silly
think
question would
that
be
sure.
uh,
Good.
so like will we be storing space like will be giving space like this exactly the same space for each key value pair, the maximum space?
What do you mean by that? Give an example.
Let's say we have one URL of just 10 characters and other of 2000 characters.
Okay.
So in our database, both will take up the same space or different?
So fair enough. Good question. This sort of depends on the kind of database you choose, right? So if you choose
Yes.
something, let's say, like MySQL, for example, giving a very simple example, or since I'm working on SQL Server, it is Microsoft SQL Server, for example. Here, especially in relational databases, you sort of define the length of the column that you'd have. So to answer your question, in the case of relational databases, we would probably have the same length as the column, as the maximum length of the string that's possible. And that would mean that even a character with 10, even a URL with 10 characters and a URL with 2000 characters, both would consume the same space. However, if we move, uh, hmm, not sure. So let's assume there is a certain database which I do not have a lot of idea about, which allows us to sort of do this. Then we obviously that is not the only limiting factor, right? There are other
Yeah.
factors as well, but that could be a favor, sort of a favorite point or a favoring point of the other database that we have. But then, very honestly speaking, and at least in my experience, essentially storage is cheap. Disk storage specifically is cheap. Okay.
Okay.
So when you come to making a call with respect to trade-off, cost is a very high factor when making these trade-off calls, and you would typically be okay with making this trade-off of wasting that amount of space. because it's disk space, and disk space is sort of very
Okay,
cheap
so
and all
one
that.
more thing.
Mhm.
There are like in-memory databases as well, right?
Correct. There are.
So, so would they like the memory using there and our disk space? Is that any different? Like, basically, we are using uh different SSDs, I guess.
Uh, so with respect to in-memory databases, uh, again, that's sort of a longer conversation, and we'll sort of get to that. But you in-memory is obviously more expensive than disk, correct?
Yes.
Uh,
Yeah,
yeah. So then it sort
but
of
it's
depends
faster.
on your scale as well. Sorry.
Yeah. But it's
Go
faster,
on.
right?
It is faster,
In
of
memory is
course.
this. Yeah.
Of course. So the trade-off that you are essentially making over there is is basically cost and latency, right?
Yes.
You are saving, let's say, an additional 1 second, maybe, right? Or even 1 second is pretty high. But let's
Yeah.
assume 1 second. All right. So are you okay with a customer waiting for 1 more second and you incurring that higher cost? Or are you okay, or sorry, having lower cost? Or are you okay for that customer? That customer is probably not okay spending that 1 second, and you're okay with spending that amount of money so that you give him that 1 second, or give him or her that 1 second. Does that make sense?
Yeah. So basically, for like
Mhm.
for humans, 1 second is not a higher, like not a long time.
Mhm. Yeah. So
So,
again, 1 second is a figure that I've told. So essentially,
but
what you do
it would
is
not take 1 second, right? Like it would be lesser than that, basically,
it
most
would
likely.
probably be lesser than that, is what I understand. So basically, what you do is, this is another concept. So when you're sort of evaluating between different databases, right? And we'll sort of come to that as well. But when you're evaluating between different databases, you do something called as a load test. Okay, so you test various technologies at different loads. You look at their response times. You look at their memory consumption patterns. So let's say 10,000 URLs in a relational database and in a non-relational database, and I think, if I am not wrong, and I'm not very sure of this, but even in several relational databases. So, for example, if you used Oracle DB versus maybe Microsoft SQL Server, and depending on how you define your schema, uh, you could find a difference in the amount of storage that you're consuming. Okay, which might
Okay.
probably not be a lot, because all of these databases, when you sort of look at database internals, which is a much more interesting topic, and how data is stored, different databases have different techniques of storing data, and that sort of affects other parameters as well. So so basically, coming back to load tests, so you would essentially do load tests on each of these databases, see the patterns in data, and see what you care about. So in our case, let's say we care about latency, right? We don't really
Yes.
care how much storage we're taking, and we'd probably go for an in-memory database, because that will ensure we have minimal latency with respect to our data, and that will probably allow us. But one problem with in-memory databases would be you wouldn't really be able to scale after a certain point. So our big plan of deploying it for all engineering colleges across India to use this URL shortening services might actually prove very expensive for us. So scalability in
Yes.
itself is a big sort of factor as well. And yeah,
Yeah.
does that
So,
answer your question?
yeah. So here, basically, we can trade off a few milliseconds with cheaper memory and like more
Yeah,
users.
cheaper memory and essentially basically cost. You are trying to save money by giving, I wouldn't say bad experience, but not as great experience as what you would probably get.
Yeah.
Does that
But
answer?
that's tolerable. Like what we want to achieve is basically tolerable experience. Uh, like good enough,
Yep, you're
basically.
right.
Not.
Yep, yep. So like I said, right, requirements is the most important part of any system design, and understanding the requirement and spending a lot of time on it is super important, and putting it on paper. The most difficult part of software engineering is putting requirements on paper, because once you put it on paper, then when you move things out of your head onto paper, that's when things start to get realistic, because in your head you can imagine anything, and 10 different people are always imagining 10 different things. But once you put it on
Yes.
paper, people start to align, and then you sort of it becomes easier to finalize things and get on with them. All
Yeah.
right,
So
so
one
yep.
more requirement can be like we can define maximum latency,
Okay,
the
yep,
maximum time which our
that's
server takes.
okay. So let's say maximum latency would be, is there a number that you have?
2 seconds max. It shouldn't be
Oh,
more
okay.
than that.
So so here's another concept. So I'll randomly keep spitting out concepts because as to whatever I remember. Okay. So latency. Let me see if this is a yeah. So this is a very important concept
Yes.
called latency metrics. Okay. So
Yes.
typically no one looks at 50th percentile. People look at 90th percentile and
Fine.
99th percentile. Okay. So since we were talking about latency, so basically what happens, right? Is there a graph here? So basically, your latency, all your requests will not serve at the same time. Very
Yeah,
simple
there will be
example, right?
outliers.
There will be outliers, but more than that, it's sort of a graph, right? So
Yes.
and as your percentile of requests increases, so your graph. One second, let's see if we have images. Uh, so there's a very nice graph of time versus latency. Not this. Not this. Okay. This is still okay. So if you look at this graph, right, we have P5th, P95th. Okay. So so basically the latency graph is sort of like an increasing graph. Okay, but it's not linear, obviously. It follows, it's some sort of a weird curve, which I don't really have right now. But so what we mean over here, right? So let's say if you have 100 requests, right? And you sort of sort them in increasing order of, an increasing order. Then P5th would mean the first 5 requests. P95th would mean let's look at the definition over here. 50th
9th
percentile
percentile,
latency.
I guess.
Yeah, percentile.
P. Yeah.
Screen visible. Yep. 50th
Yeah.
percentile latency and maximum latency in seconds for the fastest 50% of all requests. Okay. So what that would mean is, if you sort your requests in let's do decreasing order, or let's say increasing order, the 50th percentile would be basically the time taken for those requests. This is also called median latency. No one cares about that. What we typically look at is 90th percentile, so or it's also called P90th and P99th. Okay. So and P99th would be the maximum value. So if you look at this graph over here, you would see that P95th, you see these peaks that are coming up. These are basically times when your requests have either sort of your throughput has suddenly increased. Throughput basically means the number of requests that we're sending. So the number of requests can also increase. Or in this case, we have constant requests. But let's say if you're, so there are various reasons why your P95th or P90th could increase. Okay, one of the reasons is high throughput. Basically, your system is now serving more requests, so it's taking more time to process those requests. Okay, or it's taking more time to process the 95th P95th. Then there's P99th, and your P99th is basically the last 1% of requests which take a lot of time. So you might see a certain amount of timeouts. So there's a bunch of concepts around this. So whenever you define latency, you don't define latency in terms of my request should be 2 seconds or whatever, 2 milliseconds. You define it in terms of P90 and P99. Does that make sense, guys?
Yeah, it makes sense.
All right.
So,
Yeah,
one other question.
yep, yep.
You guys would do performance testing for iris servers also, right?
So during my time, I don't think we did it. I do know they are trying out certain things right now. I think they've done a bunch of load tests for Moodle and a bunch of stuff last year. I don't have exact details, but yeah, I think there was like a bunch of stuff done last year for Iris.
Oh, okay, okay. Yeah.
Okay. So yeah, coming back to system design. Essentially, so what I was talking about is how we basically choose databases. You run load tests on each of these, and you see metrics. You see latency metrics. You see. So then, apart from this, there are also system metrics. Let's see if we can show you guys system metrics. Nah, yaar. So trying to look for a graph. Sorry. Yeah, something like this. This is probably a good example. Grafana, great. Session cookie, again. No, not this. So I think next time I'll probably keep researching some. Yeah, I think this is a good example. I'll research and keep images for you guys. Not this. So essentially, there are system metrics that you can sort of keep, and as your number of requests increase, or as you sort of scale, okay, we'll sort of cover that later. But as you sort of scale, you start looking at memory. You start looking at uh, you can look at logins, logouts. That's another metric. But you also start looking at your P90th, P99th to see how they are faring, and based on that, you sort of make a call whether you want to go with that particular database. It also depends on the kind of technology you're using. So if let's say, since we'll sort of be writing an application for the URL shortener service, using Node.js versus using Golang versus using Rust, something like Rust, versus using any other piece of technology, Ruby on Rails, Django, all of these particular things, then coupled with a certain database, uh, you would do all these combinations before making a call as to which system is it that you are looking to write your technology with. Does that make sense for us? Let's talk to Sushant. How are you, Sushant? Sushant, can you hear us? I believe you're on mute. Am I still audible?
Yes, you are.
Yeah.
Sure. All right. Hi, Sushant. Is your GSOC over?
Not yet. Second phase of coding is going on.
Okay. I think you're not as audible. Can others hear Sushant?
Am I audible now?
Yeah, much better. Awesome. All right. So let's come back, Sushant, back to requirements. I think let's see how far we go. I don't think we'll be able to finish entire system design today, but because I keep diverting and I want to keep diverting. So Sushant, you worked on Ruby on Rails, right?
Yeah, yeah.
As part of GSOC, and what was your GSOC project? You were working on a
No,
certain library.
no. I didn't work on Ruby on Rails in GSOC. I worked with Ruby type systems. Like a new type annotation system
Oh
was
yes,
released with Ruby
sorry.
3.0.
Mhm. So
So I
you
was working
essentially
in that.
did type validation in Ruby 3.0.
Oh yeah, I mean the language was introduced, right? RBS. It's called Ruby signatures. So that language was introduced. I worked on writing RBS for few standard libraries, and then I started contributing in fixing issues and adding more features to RBS. So currently, I've landed
Got it.
three PRs
Got it.
on three fixes, three major fixes.
Okay. Okay. All right. That sounds super nice. I think I'll probably have a separate conversation with you offline about that as well. But coming back to this, any other requirements, Sushant, that you think we should probably have?
I guess to start off with, this should be good. We can decide once we, like at least we should have a basic system. I feel once we do that, we can always add features or enhance the working of the system.
Okay. So let me still introduce two more things because those are something which I think we should probably address now. One is Sushant. So let's say we were talking about events, right? And we said that every year we'll sort of conduct event. Every club we made a number of about 500 events. Now let's say so now we see a bunch of constraints over here, right? One is if I have a particular URL, okay, and let's say if I have a particular event, let's take engineer for example. I've created a bunch of shortened URLs for engineer, or let's say I've created one URL for engineer, one shortened URL for engineer. I know that after a year, I'm probably not going to use it for the next entire year, and no one's probably going to hit that URL, and that's the first part of it. And the second part of it is, let's say I sort of add even a year value to it or some unique value to it, right? Saying engineer 19 or whatever, and some character, since we've said that our values can only be characters. Then that URL is probably not going to be used, and it's just going to lie out in our storage. And over time, if you sort of compound this in a very scalable manner, we are going to have a bunch of URLs which are going to just sort of lie in our system and not going to be used. Does that make sense?
Yeah, definitely.
So my question to you is, one, can we do something about URLs like these? And two, let's say as a user, I and this sort of depends on the requirement that you define. It can go either way. Where as a user, I know like the service name is bit.ly, for example, and I enter any random URL, and it redirects me to a different page. It redirects me to a certain page. Let's say that URL exists. Am I okay with making such predictable URLs, or am I not okay? Did you get the two questions?
I didn't get the second one.
Okay, we'll come to the second one. Let's talk about the first one.
Okay, I feel that for the first one, probably notifying the users that in in a scenario where your URLs are no longer being accessed, we might remove it within a span of a week, because storing useless URLs in the database makes no use either for us or for the consumer also, right? I mean, just because they would want to store it someplace, maybe I mean that would not be the right thing, right? So I feel we can delete it from the database, and in case they do require, they can we can have two options here. One is they can say that no, we are going to reuse it, so please continue it, like continue using it. We can give an option wherein wherein the customer or the user can say that no, please continue this URL, do not delete it from the database. Or the other thing being, we would delete it from the database after notifying the user that in case of no response in 7 days, or maybe 2 weeks, or whatever span we decide, we will remove it from the database.
Mhm. Okay, so there are a couple of things over here, right? The 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 time that we decide, or rather the decision that we take to incorporate the time, right? So we are saying, well, now we've just put in one requirement, but the beautiful thing about system design is you suddenly start to see how it affects a lot of things, right? The moment you say, okay, you know what, Sushant said that, you know what, we have this requirement that we want to save storage. Okay, we've kept a constraint of 1 week. Okay, now there's a bunch of stuff that that you've already added, and the reason why I'm sort of trying to explain is, or the main point that I'm trying to put across is, every decision will affect a bunch of stuff going forward, right? So the moment that we say that, there should be a default time span, the first thing that you need to do is you need to store the time span. Okay, now once you store the time span, there's a bunch of stuff after that. You would probably store, when it was created and updated, for example, just to start off. The next thing that you would store is when it was probably last hit, so that you can compute if it sort of has that 1 week, and if it's past that 1 week, then we would automatically delete it from the database. Now, how would you delete it from the database? So you probably need to have some sort of a background thread which keeps running, which checks and or maybe some sort of a cron job, which maybe at every day at 2 o'clock or 3 o'clock checks your database and says, you know what, hey, this is past 1 week, and we sort of need to remove this entry, and and sort of define that. And another thing that you probably add because of this is, every time your URL is hit, do you keep updating your database on disk? Because database disk operations are expensive. Any database operation is expensive, because you will keep hitting your database over a network call, right? And your database is probably in a different box. Your main application is in a different box. So you need to keep updating that. Another way of doing it is probably storing it in a cache with a expiry period of 7 days, and and have some sort of a logic which says, you know what, if the URL is not in the cache, which means you probably delete it from disk as well. And again, I'm not going to again, we'll sort of talk about the implementation of this. But what I'm trying to give over here is, we just added one constraint saying, you know what, I don't want things after 1 week. And there's a bunch of 10 to 15 decisions that I suddenly need to start taking as to what is to be added, what is to be done. Does this point make sense?
Yeah, definitely. This affects a lot of things, right?
Correct, correct. But since we've defined this as a requirement, we will add it. So 1 week of cache in the database. Sorry, not 1 week of cache, but 1 week old URLs in the database. Okay. So when we say 1 week, do we mean 1 week from creation, or do we mean 1 week from last hit? Is the next question.
I would say 1 week from last hit, because that is
Okay.
more user friendly. I mean, again, here it's a trade off. Like, you need to decide based on what your thoughts are about it. Like, I would say, for a better user experience, I would say it should be based on the last hit, or the last update to the URL, or something of that sort, wherein it's more about
Yeah. Mhm.
the updation and access, and not about the creation.
What do you mean by updation?
I mean, basically, when was the URL last updated? Like, basically, if I'm accessing the URL, we can possibly consider it as I mean, it being used, which basically, I mean, it's not right to say it's being updated, but it is being used.
Mhm.
Like, that would be the right term. So I would say, for a better user
Yeah,
experience,
because go on.
yeah, I mean, for a better user experience, it's better to have the last hit, like, based on the last hit, we decide whether to delete it or to not.
Okay. So what we're saying over here is, whenever it was last hit, 1 week from there, we will, yeah, I mean, if the URL has not been consumed for a week, we will delete the URL, given it's a custom URL or whatever. And and this is where, sort of business sort of creeps in. where you suddenly, and this is slightly off topic from system design, but if you are running a business of a URL shortener, this is where you say, you know what, if you are a shortener, I will give you 1 week of URL from, 1 week from the last hit. We will store your URLs. If you are a slightly standard customer or whatever above the next tier, we'll probably give you a month. And if you're a premium customer, we'll give it till forever or till whenever you're premium. And because your cost also depends on stuff like this, your cost wouldn't be affected by storing URLs in probably a relational database, depending on the scale of your system. But this is how the business creeps into system design. And obviously, most of us will eventually design system or design software for making money, unless someone goes into non-profit open source, which is a noble initiative. But this is something that, so money is a very important factor when designing a system, and how your system will make money in itself is a very important part as well. Okay. Especially if someone is, I mean, you obviously can, your product can in itself make money, but then there are certain, I mean, there are different ways of making money. This is like one of them. And yeah, just want to sort of put it up there. Let's go with someone else. I see Adarsh is in the call. Hi, Adarsh. How are you? Hi. All right, Adarsh. I have one last requirement before we sort of move in. Uh, my and This is a slightly straightforward question. Let's say, so the first requirement that we said, that given a long URL, return a unique shortened URL of 10 alphabets, right? And let's say, for a certain reason, one of the unique shortened URLs is all A's, right? 10 A's. And now anyone can sort of put in values and access this URL. So that opens a security constraint. Let's say we have a shortened URL to this particular meeting, right? Which is, if anyone on the internet can type anything and reach this particular URL. So my question to you is, are we okay with this requirement? Do we want to put some sort of a gatekeeping, or do we want to change something in the algorithm to ensure that no one can probably guess a particular URL, or we reduce the chances of someone, the more randomized. So the basic idea is, the more randomized that you make a URL, the more chances of it, of a stranger landing on that URL, the more difficult it becomes for a stranger to land on that URL. But the trade-off that you are facing over here is, your randomization in itself is, well, it could or could not increase the complexity of you computing the shortened URL. Does that make sense? So the question to you is, what is your requirement? Are you okay with people randomly landing on your URLs because these are just URLs, or you would want them to sort of, yeah, go on. Mhm. You know both, right? You So what do you think? Yeah. Mhm. 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 So by password, you mean some sort of passcode, like I think how Zoom probably has, right? Okay. Okay. Go on. Mm-hmm. 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 Okay. Sorry, guys. I just need to charge my phone. But yeah. So, yeah. I mean, what Adarsh said was absolutely right. And again, this is where you again sort of define your premium tier and your non-premium tier, as we would call it, where you say, let's say, so that is one way of going about it, where you say, you know what, if you're, let's say, a premium customer, I will also give you an option of storing a password along with your links, so that you are allowed to share private links as well as part of the URL shortener service. But from what I can see, and the kind of requirement that we have, which is just, and again, that could also change. Even college, you might want certain college events to be private to the college. Might want certain college events to be public to everyone out there. It depends from case to case. But yeah, I mean, so that is how it could go either way. In our case, I think others has said that, you know what, let's probably have a password as well for certain events and maybe for certain not. So you have some sort of an optional field saying, if this is a high priority event, or if this is some sort of, let's say, a faculty, or it need not even be an event, right? If it's a certain page that you want to share, and you don't want everyone to get the link of it, or whatever use case that you have some sort of a simple authentication for it as well. And yeah, but the moment you add that simple authentication, you are again cascading it into 10 different decisions about a bunch of other stuff that you are probably looking for, and you need to account for storing all of that as well. And again, your database size increases, your lines of code increase, just to start off. Once your lines of code increase, your algorithmic complexity increase, because now who is going to generate the password, who is going to generate all that stuff that you need to sort of build on this. So yep. So the basic idea behind sort of giving these two requirements was to explain the fact that every requirement you add increases, firstly, the engineering effort to ensure that requirement comes true. Second, increases the complexity of your system. Third, adds dependencies to your system, which makes it much more complicated to design, makes it a much harder problem statement for you to solve. Excuse me. And more importantly, I think it affects your entire architecture, and probably in the long run, what is the kind of technology that you might use. So certain technology might be, or a certain database or a certain backend technology might be proficient in certain things, which something else might not, and your requirement can entirely change the entire decision of choosing something. Okay. So yep. So let's probably add that. Links should optionally have some form of authentication. Okay. I think we were scheduled till 8, but I have a hard stop at 7:30. I have some work stuff to do. So what we'll do is, we've talked about URL length. Let's uh, So one important factor typically after requirements is, or rather as part of requirements itself, is traffic estimation. Okay. So you try to sort of estimate what is the kind of traffic that you sort of land with. How you would do that is, there's an event at NITK, for example, to start off. You publish one event, you publicize, let's say, in 10 class groups, or maybe, yeah, let's assume 10 class groups to start off. Each class has, let's say, 100 people. So that's 1,000 people, out of which you expect, let's say, 30% of the people to click on the link. So 30% of 1,000 is about 300. You have 500 of these events, so 300 into 500, that gives you 15 into 10 power 4, which is 150,000 or 1,50,000. And if you do this over 5 years, you would probably have 7.5 hits, 7.5 lakh hits, or 750,000 hits to your service. If you, let's say, stay at an 80K, and then you sort of extrapolate numbers based on the traffic. We've already calculated what is the number of records that we're expecting. We said about 500 events, or 500 records, and then over 5 years, or 2,500 records. But if you, let's say, then the next step would be, first 2 years we would do this in NITK. After that, we would do this in Karnataka in the third year, and the fourth and fifth year we'd expand all over India. And then you sort of compute the numbers accordingly. Okay. So this is basically how you do traffic estimation. You typically expect your numbers to grow over time. And yeah, I think I also, another thing that I think I missed out is, you would expect people to sort of repeat. So what I did right now is assume every user would just click once on the URL, which is not really true. It is a slightly more complicated problem than that. So you sort of take an average. Some users might click once, some users might click 3 or 4 times. And you say, maybe, what, at the end of the day, you might have, like, on an average 2 clicks per user, and then you do the entire computation. Does this make sense, guys? I hope I'm making sense.
So
Let's.
these are all estimations at this point, right? Like, we're just assuming that
Everything
we'll
we're
have
doing
these
right
many clicks.
till now is estimation. Absolutely.
Right.
So everything we're doing till now.
So would it be better to actually store these metrics? Like, let's say we have one event, we store the metrics of how many people actually attended, and based on that, we can, interpolate values? Or just is estimation always like the go-to method of
So
seeing your
you
worst case
can
scenario?
obviously do it for one event, but you sort of extrapolate whatever information you have. Obviously, one event is not a great metric. When you're starting off with a service, you obviously have lower numbers, and as you grow, you have higher numbers, and that sort of compounds. So I would say having one event is a good start, but will not even give you approx numbers, to be honest, rather than accurate numbers. So yeah, I mean, what you can do is, yeah, I mean, you can take those numbers, but again, uh, always assume that there is error in the computation that you're doing. Yeah, I hope that makes sense.
Yeah.
So typically, even when you do estimation, you sort of assume error and add that as well. So, for example, when I said, right, that let's assume there are 400 we have 400 people who would 400 events per year at an ITK. I added 20% to it, which was approximately 480, and then I said, you know what, let's make it 500. Correct. So you sort of do that kind of an estimation, and hope that you might be off your estimation by some number, but not by a huge number. That's the whole idea. Uh, but yeah, I mean, that's how you sort of define traffic. What that typically helps you to do is, or rather why we do this estimation is because after this, at the end, once you sort of make your entire design and stuff, you're supposed to run load tests, right? So you need to know what numbers you need to run it with. You just can't take any random number and start off with, right? So you need to have some value where you're supposed to hit your system with, and see how your system scales with respect to those values, and accordingly add stuff based on that. You would add queues or add some sort of a cache, and you would sort of compromise on cost so that your system becomes faster at higher loads, or you are probably not hitting a system with that much amount of load. It depends. It goes on, and it depends on a lot of stuff. And if you look at a URL shortener service, right, the first time when you create the URL is the more computationally intensive part. The part after that is just making network calls and fetching the value and then sending it back, right? So if you have to do a computation every time, let's say if you have some sort of an algorithm which sort of only computes a particular URL every time, then that's problematic as well. So yeah, uh, that's the reason. I hope we've sort of got that. Does that make sense, guys?
Yeah.
Okay. So I think we've come to a logical stop. If I start something else, then that is going to take a bunch more time. What I would suggest all of you do when you get back is try to take up a system design question. You will find many. There's parking lot. There's like a bunch of stuff. Let me probably share one particular resource which I at least use to watch system design videos. This is obviously not the only thing out there. Give me a second. So his name is. I don't think I can find it here. So he has an interesting video on Tinder design, Tinder system design.
Are you
Yeah,
talking
this
about
guy,
Gaurav
Gaurav.
Sen?
Yeah, Gaurav. So take a look at Gaurav Sen's videos. Oh, I haven't subscribed. Yeah. Okay. So take a look at Gaurav Sen's videos. He has a bunch of videos. He explains a bunch of concepts. Okay. Basically, how do you start with system design? And there's a bunch of concepts as you go ahead. This is a video that I had watched primarily out of curiosity, and then I think I watched a lot of his videos after that. And so sort of do go over this. What I would say is probably actually coming back on my advice itself, don't start off with system design problems. Start off with system design concepts. So I was looking to cover a few of these today, but maybe next time or whenever we get a chance. But try to understand these concepts, then probably move on to problems. I mean, problems is again very subjective, right? He'll explain one approach, you will tell one approach. It all depends, as we just saw, on how you define requirements and how you, basically how you define requirements, right? So if you've defined a requirement completely differently, then things would move on to be completely different. But yes, I think that is something. This is a good channel to watch. There's a bunch of other channels as well, but I think this is a good one to start if you're a beginner. I think he started some company as well for interview ready, but I think that's majorly DSA. Not sure. Okay, let me not play that. Yeah. Any other questions, guys? Let's see who has not talked. Okay, we have a bunch of people who have not talked. We will get people to talk some other time. Shashank. Shashank is the organizer. Shashank will tell us any questions, Shashank.
Hey, sorry, I was not able to unmute.
That's
Yeah,
okay.
I don't have any question, but
Sure. Any questions you guys have for me apart from like system design? I think also we can stop the recording. I think this is good. If someone wants
okay,
to conclude, they
maybe
can conclude.
just a another point regarding the authentication part. If we could head over to the doc.
1 second. Mhm.
Yeah, I think another authentication that we could add is add a checksum to the URL. Basically, very short checksum so that the major problem of people randomly creating, randomly adding characters to URL and hitting some actual URL will probably be solved.
Would you do that
Then,
for your class? Go on. Sorry.
yeah, basically add a very small checksum to shortened URLs.
Okay, but would you do that for custom URLs as well?
Yeah, we can definitely do that for custom URLs also. So the secret to create the checksum will be stored with the URL shortener service. And if anyone tries to change the URL, then the checksum will be different and the checksum doesn't match. That's just a suggestion which can be done. That's what I think. Instead of
Yeah,
using
obviously,
passwords or anything.
it can be done, but coming back to you itself, what do you think is the trade-off that we are making if we are introducing this? This is the good part, right? Where you're saying,
Mhm.
you know what, I want to make things more secure. What's the downside of this that you sort of see?
Yeah,
Everything will have
definitely
a upside and a downside.
yeah, the downside would definitely be convenience. The URL gets a bit longer now due to the checksum part. It may not be a shortened URL anymore sometimes. Uh,
that
and
that absolutely.
yeah, but
And
we can try to keep the checksum as small as possible. That's also fine. And any
let's
other,
say
yeah,
your
that
checksum is 5 characters. Okay. So now your unique shortened URL, which you're storing in your database, also increases by 5 characters. Correct?
we need not store that. We can handle that somewhere else in the code logic, but I don't think
Wherever
we
you're
need to
storing it.
store. Yeah.
Oh, okay. Then how would you compute your checksum?
Checksum is basically we take a hash using a secret and the whole URL. So the secret would be
Okay, you
stored
want a
with the
global
service.
C. Okay, you want, yeah. My question was basically with respect to secret is, okay, yeah, it's sort of a global secret. Fair enough.
Mhm.
You could do that. Uh, how does that improve security?
If you change the characters, or if you just randomly type some characters, probably you can't find out the checksum since the secret is unknown to that person.
So you send the checksum as a params in the request.
Yes, yeah, in the URL.
Okay, and let's say I am registered. How do you differentiate between a person who's clicking the shortened URL from, let's say, a WhatsApp message to a person who's randomly typing it in his browser? Or how do you differentiate between a genuine and a because both of them are entering the URL in, let's say, your browser, right?
Hmm.
How does the checksum help? Just trying
Um,
to understand.
okay, let's say if if our URL was bit slash abcd, and you have a param called checksum.
Okay.
So bit.ly slash abcd ampersand chk equals to some a random checksum. And if the person tries to say, if he tries to go to abcde, if he adds another character, and when he hits that URL, in the backend, that is in the server, we can do the checksum check. Basically, again, we create a checksum of the sent URL against the sent checksum and compare it.
Okay. Fair enough.
Yeah.
But okay. But again, you're doing a bunch of stuff with respect to
Mhm.
that, with respect to experience, with respect to just computation of checksum in itself
Yeah,
is
it's
what
going to
would
be
cause sort yeah
a
is
lot of
will take
processing
some
power
time,
and
right?
all.
Yeah.
Yeah.
So basically your latency will increase, and then we talked about P90 as ninth. So if you're
Mhm.
whatever, that value will also increase no
Yeah.
matter what how simplified the computation is, right?
Mhm.
I mean, so there is a trade-off, like I said. With respect to adding features, we can add any n number of features, right? The question
Yeah.
always is the trade-off and whether the trade-off is required or not.
Mhm. Yeah.
Yeah. Yeah, I mean, this is probably a longer discussion, but yeah, the message that I sort of want to pass across is making trade-offs. I mean, that's the entire message behind system design. That every decision that you take has trade-offs and far-reaching implications ahead as you go about.
Yeah, right.
Okay. Yeah, I think a recording you can stop. I don't think I have anything else to talk about. We can chat / we can head out. What do you guys want?